Hello, everyone. My name is Manuel Aarón López Pérez. I'm the first author of this work, and I'm from Mérida, Yucatán. I'm studying at the Instituto Tecnológico de Mérida, and this work is named User Interface Design and Object Segmentation Applied to the Autominy platform. My first director of this work is the Jesús SANDOVAL. The second director is Freddy and ANDRADE, and my third director is Julio MOLINA CÉSPEDES. This last from the Universidad Politécnica de Yucatán. I'd like to start talking about the content of this presentation, starting at the introduction, then next to the methodology, results, and finally conclusions and reference. This works proposed two principal tasks. The first one is implementing and creating and implementing a user interface for the Autominy platform, and then developing a algorithm that can segmentate the obstacles for the vision to the Autominy platform using point cloud library, and this to facilitate the management of the amount of point processing data. I'd like to start talking about the Autominy platform. The Autominy platform is a robot created by the Free University of Berlin and donated by the CIMAT to the Universidad Politécnica de Yucatán. This this platform has a LiDAR sensor, a depth camera sensor, gyroscopes, and many other sensors that can control the speed, direction, and torque of the robot. This robot was made to demonstrate the autonomous conduction of the cars. So that's why we choose to develop to this platform this kind of algorithm to segmentate the objects and apply it to this platform, and then on the future we can we can replicate to the other autonomous cars. So the main problem is to the complexity of the control of the Autominy, is because this control is based on the terminal, on the command terminal, and that for the user experience is not very intuitive. So that's why we propose to create the user interface to control to enhance the control of this robot. Also, another problem to solve is to presentate or develop another or alternative algorithm to detect objects segmented, and in the future maybe we can avoid them. So this using the depth camera from the robot. The depth camera is an Intel D435 camera, and it's special because you can use as a normal camera or a depth camera. If all of this, we're going to use ROS, that is a robotic operation system, for controlling all the parts, all the actuators from the Autominy, because ROS has the ability to perform many tasks at the same time. Okay, so here is an example. For example, the microphone. The microphone. We can use speech recognition, and then we apply to the, for example, another speaker or actuators. So that's the facility that ROS has to control or to perform tasks via publishers and subscribers. On the connections between the publishers and subscribers are called topics that contains the data sending from different sensors. Also, we use KVMD to develop the user interface, and that's why we choose KVMD for the integration with ROS for using Python. Also, the PCL library, the point cloud library, use also C++. That is a language that understands by ROS. That's the integration is very well completed and is easily to apply. So PCL has the package to compile and to apply the dimensional planner segmentation methods. So that's why we choose PCL. Finally, here is the integrations of everything to the control via ROS, KVMD, and PCL. Talking about the planar segmentation methods, the first one is the octet method. This is used to downsampling the data. This to enhance the processing time of the CPU that has the Autominy, and then the KD3 method. This to search the nearest point to the objects that we are tracing, holding the point from other blobs of objects. Here's an example of the code, how the code works. Then we initializing the rows node. We are creating a subscriber and publisher. This to communicate sensors to actuators, and we are reading the data from the real sense camera for the depth camera, and we are transporting or sending those data to the via ROS topic to the ROS processing method. We are converting the ROS to PCL data type. Then we are downsampling using the octet method, this to enhance the time processing. Then we are creating a KD3 object, this to segmentate these objects that we are seeing in the camera. Then we are converting back from the PCL to ROS, and finally we are sending the data via ROS publisher, and this we can in the future processing and knowing where they are, the objects, and avoid with the actuators those objects. This algorithm is just for applying the segmentation method. It's not applying the evasion method. And there maybe in the future works we can apply the voiding method. So at the time it's just the segmentation algorithm. My results here we have on the left the user interface controlling with the arrow buttons. We can control directions. We can control speeds with the sidebars, the steering. We have a stop emergency stop button, and we are seeing on the via web server where we where what are the Autominy seeing, and on the right we have the results of the segmentation objects. Above up we have the the segmentation very in a very specific thresholding value, and above and on the bottom we have a wide thresholding value. So there's a difference to seeing the objects. It's interesting how we can notice, for example, the detailing. We are having the first image, and the second image we are not having detailing object segmentation because the parameters setting on the algorithm. To summarize the work, a user interface was created using KVMD and ROS and Python, and sending the information via ROS node, and the camera was streamed via a web server. Also, in addition, a clustering algorithm was implemented to enhance the perceptions, and to proposing uh, another method to segmentate objects. Of course, using the point cloud library, and applied it to ROS, and I think that's all. The reference are mainly taken from the Autominy page of GitHub, and the work was based of the Borges Montreal and Garcia Lopez and Molina Céspedes previous work, and take it and to enhance to propose another method to control the Autominy. And finally, the rows documentation, this segmentation, the point cloud processing information, and I'm very happy to present you this work, and I hope you like it. Um, and I have to say goodbye. Thank you very much.